When we're sending spacecraft to other planetary objects, when we're trying to explore the solar system, the first question that we ask is, where are you going? What kind of mission are you sending? Because if you're sending a mission to a place where there is no chance for Earth life to survive, and you're not looking for life at that location, then the requirements are pretty much just document what you're doing. Where do you leave your spacecraft?
Yeah, actually where I am, it's almost like the moon is rising.
If you're going to a place like Mars and you want to do life detection experiments, then we have quite strict requirements on how much Earth life and how much Earth material do you bring with you on your spacecraft. If you're going to look for life on Mars, or you want to look for life somewhere else than the Earth, it's really important not to bring Earth life with you. So in this cave, there are organisms all over the cave. We just can't see them, and they're not abundant. You can see there's dripping water around me. This water is constantly permeating the cave. It comes from the surface. It has to pass through the ground above the cave, and that often is a mechanism for organisms to be transported from the surface downwards. The best way to study life is to get it back in a laboratory on Earth and investigate all of the characteristics. Most importantly, if you're trying to bring samples back from some other location to Earth, it's very important not to bring something nasty back with those samples, so we try not to cause the Andromeda strain. When we design life detection experiments for other planets, we have to consider what kind of life we expect to find. For the Viking mission, that was the first mission to send life detection instruments to Mars, we didn't know about all this extreme life. The Viking life detection package was designed to find organisms that are living in environments similar to the environments that humans consider hospitable. When the Viking mission was launched to Mars, we didn't know about hydrothermal vents and the organisms that live at the bottom of the ocean. So those life detection experiments were trying to find both the components of life, the organic compounds, in the mass spectrometry experiment, and also trying to look for reactions that would indicate life in the labeled release experiment. The labeled release experiment on Viking actually did observe reactions that released labeled carbon-14, so we did see a signal from that experiment, but that signal is consistent either with organisms being present on Mars or with reactive compounds to be present in the soil of Mars. But there are viruses in your drinking water, there are viruses in your bath water, there are viruses in the rocks around us that don't infect humans. There are viruses associated with the microbes, with the biology that is present in the environments that we all are in. So most viruses are totally harmless. In some cases, in fact, medical science has been able to take viruses that do infect humans and use them to alter the physiology of human beings and potentially cure diseases.